Hello everyone. So this is a question from JEE Mains 2026 6th April Shift 2. Given below are two statements. Okay, so we have a container and it is divided by a SPM into two chambers. Chamber 1 has 18 gram glucose in 100 ml aqueous solution and chamber 2 has 30 gram glucose in 250 ml aqueous solution. Okay. Statement 1. H2O molecules move from the chamber 1 to chamber 2. Okay. Statement 2. The osmotic pressure of a solution prepared by dissolving 50 milligram of potassium sulfate, whose molar mass is 174, in 2 liter of water at 27 degrees Celsius is 0.0107 bar, and R is given to us, and the unit of R is important: dm cube bar Kelvin inverse mole inverse. Okay, and assume complete dissociation of electrolyte. Okay, so we have to tell which statement is correct. The chapters involved is solutions. So in the diagram, our container or the beaker is divided into two compartments by a SPM. An SPM is a semi-permeable membrane, and it is a membrane which allows the solvent molecule to pass through but not the solute particles. Okay, so the solvent can go through from one chamber to another chamber but not the solute. Okay, so that is important. SPM allows only solvent to pass through, and in our case the solvent is H2O water, and solvent will flow from the chamber where it is present in higher amount to a chamber where it is in lower amount. Okay, so that is with respect to amount of solvent. The solvent flows from a higher amount of solvent to the chamber having low amount of solvent. So this is the direction of flow of solvent. Okay, and we know that concentration of a solution is the amount of solute dissolved in a known amount of the solution. Okay, important. Concentration of a solution is amount of solute dissolved in a known amount of solution. Okay, so therefore a high concentration will imply high amount of solute and obviously less amount of solvent, and low concentration will imply low amount of solute and high amount of solvent. So therefore, with respect to concentration of solution, so the solvent flows from the chamber having low concentration of solution towards the chamber having high concentration of solution. Okay, and this is the direction of flow of solvent. Okay, so there are two criterias with respect to amount of solvent. The solvent flows from the chamber having high amount of solvent to the chamber having low amount of solvent. With respect to concentration of the solution, the solvent flows from low concentration of solution to the chamber having high concentration of solution. Okay, so to determine the flow of H2O molecules, let's calculate concentration of each chamber using the formula molarity is equal to number of moles of solute divided by volume of solution in liters. Okay, for each chamber. So let's say this is for chamber 1, this is for chamber 2. Okay, so molarity will be equal to number of moles by volume of solution. Number of moles is given mass 18 in chamber 1 divided by molar mass of glucose is 180 divided by 100 ml in liters 100 by 1000. Okay, so this will be 18 by 180 into 1000 by 100. So this is 1 molar. So here the concentration is 1 molar. In chamber 2, molarity will be number of moles of solute is 30 divided by molar mass is 180. Given mass is 30, molar mass is 180. Volume of solution is 250 ml, so divided by 1000. So 30 by 180 into 1000 by 250, 4, 6. So it is 2 by 3, which is approximately 0.67 molar. Okay, so therefore you can see chamber 2 has low concentration of solution, chamber 1 has high concentration of solution. So therefore the movement of solvent will be from chamber 2 through the chamber, I mean through the semi-permeable membrane towards chamber 1. Okay, so this is the flow of movement of solute water. So therefore statement 1 is incorrect, because statement 1 says that H2O moves from chamber 1 to chamber 2, which is incorrect. Coming to statement 2. So we know that osmotic pressure pi is equal to I into C into R into T, okay, where I is Van't Hoff factor and potassium sulfate, that is K2SO4, dissociates completely into 2K plus and 1 SO4 minus 2 ion. So therefore I can use the formula I is equal to number of moles, total number of moles of particles after dissociation, divided by total number of moles of particles before dissociation. Okay, so you can see after dissociation we have 2 moles of K plus ions and 1 mole of SO4 minus 2 ions. So therefore total number of moles of particles after dissociation is 3, and we started with 1 mole of K2SO4, so I is equal to 3. Okay, in this formula C is the molar concentration of the solution, which will be equal to number of moles of solute divided by volume of solution in liters. Okay, so number of moles of solute will be given mass by molar mass. Given mass is 50 milligram, so 50 into 10 power minus 3 divided by molar mass given to us as 174, and the volume of solution is given to us as 2 liters. Okay, and R is the gas constant, and it is given to us that R is equal to 0.083 dm cube bar Kelvin inverse mole inverse. Okay, and 1 dm cube is equal to 1 liter. Okay, so therefore there is no need for any unit conversion, and temperature is the temperature in kelvins, and it is given to us as 27 Celsius. So 27 plus 273, so it will be 300 Kelvin. Okay, so therefore ultimately pi will be equal to 3 into 50 into 10 power minus 3 divided by 174 into 2 into 0.083 into 300. Okay, so when you do this calculation, you will get 10.732 into 10 to the power minus 3. Okay, so what I can do is I can multiply by 1000 and divide by 1000. In that process, this will convert into 0.0107, and 10 power minus 3 into 10 power 3 is 10 power 0, which is 1. So therefore we'll be left with 0.0107 bar. Okay, so therefore the osmotic pressure of that solution is 0.0107 bar. So statement 2 is correct. Okay, so therefore the final answer is going to be statement 1 is false and statement 2 is true. Thank you.